Hi everybody. I'm back. We're going to talk about inequalities still from the review notes from Module A. So we had gotten through equations, talked about conditional, contradictions, and identities. So we're going to look at solving inequalities. We're not going to take too long to look at it because it's very much like solving equations. Here you can see in the notes that we talked about inequality. So it's a statement saying that two expressions are not equal. So an equation says the two sides are equal, and inequality says they are not equal, and it uses one of these symbols, which I just kind of reminded you over here what they mean. So this one is less than, this one is less than or equal to. So you can kind of remember these because they're like a tipped L. The ones going the other way are greater than or equal to. So if I say that this side is less than or equal to this side, then either this side could be less than this side or it could be equal. Here it's strictly less than. This one has to be less than this one to make this inequality true. So if I said, x equals 5 up here, let's see. Switch to the whiteboard for just a second. So if I said x equals 5, like in an equation, then 5 is the only value of x that would make that true. If I said x is less than 5, then there are an infinite number of numbers that would make that true. 4 and 3 and 0 and negative 27. And since we're talking about real numbers, also things like 4.8, 4.9993, right? Anything like that, anything that's below 5, not including 5, but as close as you can possibly get without having 5. So there are an infinite number of numbers that would make this inequality true. Now infinity is kind of weird because infinity doesn't mean everything. So there are also an infinite number of numbers that would not make this true. Something like 7 is not less than 5, so it would make it not true. So anything above there. And we'll talk, you'll see on the next page also, but we graph these on a number line, okay? Because it's visually, we can't write out everything that would make this true, so we're going to show it visually on a number line as well. So in the number line, you don't have to have 0 in the middle, okay? You can just have whatever number we're working with here. And you know that this number line goes on forever in both directions. Smaller numbers are down on this side of the number line, larger numbers are up here. We're just looking at the one portion that we need. So we want to show that x is going to be less than 5. Well, if we think about other numbers on this number line, right, going this way is smaller. So here are the numbers that are less than 5. Now we can do our shading right on the number line or above it. I tend to do it above it just because it's a little bit easier to see. So we want to show that 5 itself is not part of the solution set. But I can't stop at 4 because I have all those numbers in between 4 and 5. So what we do is we put a circle on 5, but we leave it open. And that says, open circle says that it's everything up to, but not including that actual 5. Now let's say I have a different one. Let's say I have x is greater than or equal to 3, and I want to graph this. Well, there's my 3. Greater than 3 is up here. Again, I can't start at 4 because even 3.00001 is greater than or equal to 3. So I am going to put my circle, I'm going to color it in this time. It's part of the shading. So anything that's shaded is a solution to this inequality. So that includes the actual number 3. Okay. We also will talk about interval notation. So again, this is on that next page, on page 5 in those. I'm kind of just doing it all at once up here on the whiteboard. So interval notation is just another visual way to show what our solution set is. But instead of having a picture like a number line, it shows it with numbers and symbols. So if I think about this, okay. Actually, let's do another example. Sometimes you'll see we have what we call compound inequalities. They have 2 parts. So I may end up with a value that looks like this, a solution set. So this is saying 3 is less than or equal to x, and x is less than 7. In other words, my x in this case would be between 3 and 7. So if I want to draw this on a number line, I would have 3 and 7 in this order, because that's how they go on the number line. This would be filled in, this would be not. There's my line. Okay. This is filled in because 3 is less than or equal to x, or x is greater than or equal to 3. It includes 3. There's no equal here. It does not include 7. Now visually, you can see that my x is between 3 and 7, including this one, not including this one. So when we do interval notation, we're going to write our boundaries, our lowest and our highest possible value of x with a comma in between them. And then what we're going to put around the edges are either parentheses. Parentheses mean the same thing as an open circle. It means that boundary is not included in our actual solution set. Or we can use brackets. And brackets are like having a closed circle, right? So this goes along when I have just less than or greater than. These happen when I have less than or equal to or greater than or equal to. So in this case, 3 is included. So my 3 gets a bracket. My 7 is not, so my 7 gets parentheses. So this is what we call interval, writing this in interval notation. Okay, so looking at this is one of those mathematical things where there's a lot of information in this little tiny equation or expression here, I should say. Okay. So mathematicians like to not have to write a lot of things out. So this is saying my numbers go from 3 to 7, 3 is included, 7 is not. It's all in just that little piece of information. So let's go back over here and write interval notation for these. Now, in this case, I don't have two numbers as my boundaries, right? My highest it could be is just before 5. My lowest it could go down forever. I could have negative 8 million, and that's a perfectly valid value for x because that is less than 5. So it can go on forever. So if we go forever in this direction, we call that negative infinity. So my lower bound is negative infinity, my upper bound is 5. Now we know 5 is going to get parentheses because it's not included. Infinity or negative infinity, infinity's at that end, right? Negative infinity's at this end. They always get parentheses because it's not an actual number that I can get to, right? It's more of a concept that says that we go on forever. Same idea here with 3. So this time 3 is my lower bound. It goes on forever, so it's going to go on forever up to infinity. 3 this time gets a bracket, and my infinity always gets parentheses. Okay, so again, if you look at this, you can say, okay, I know what this means. This means it goes from 3, including 3, all the way up to infinity. That's where the values of x are. Any value of x in that space is going to be a solution to this inequality. Okay, so if we look at the notes, that really covers page 5, which you'll want to look at and go over on your own also, but that's where we are for that. So you can see here some practice with writing or drawing the graphs, writing interval notation. Okay, so when we get to solving inequalities, basically it's just like solving equations. Okay, almost everything is exactly the same as solving equations. The one difference is right here. Solving inequalities is like solving equations, except that the inequality sign flips direction when we multiply or divide by a negative. Okay, the reason for that is if I multiply or divide by a negative, then my sign in terms of my positive or negative sign changes, right? If I have a negative and I multiply by a negative, now I have a positive. If I have a positive, I multiply by a negative, I have a negative. Same thing with division. So when I multiply or divide by a negative number, the positive or negative sign on both parts flips, and that changes the relationship. Okay, so I have a little example here. 2 is less than 5, but when I make them both negative, -2 is not less than -5, it's the other way. So when I multiply or divide by a negative and those signs change, the relationship has flipped. So my inequality sign has to flip. Okay, so let's do an example. We'll do example 10 right there. So example 10 says x plus 3 is less than 3x minus 7. Marker's coming down here. Right, let me flip this up so this is full screen here. Okay. So let me rewrite this. So we're going to solve this very much like we did an equation. Right, we're going to move things around. We want to get x by itself. We want to get all the x's on one side. Okay. Just like an equation, at this point you can move any of those terms. You can move this x over here by subtracting it and move this x. You could add the 7, you could subtract the 3. It doesn't matter where you're putting things. So I'm going to start by subtracting the 3x. I find it a little easier for inequalities to have your x on the left, because it's just a little bit easier to understand the inequality when it's x is less than something or x is greater than something rather than the other way around. So -2x plus 3 is less than -7. Okay, I have my x's over here. I want to move this. This should not be new. This is just like solving an equation. Okay, now I get to this point. I have -2x is less than -10. I need to get x by itself, so I divide by whatever's in front of the x. Okay, as soon as you hear yourself saying that you're dividing by a negative, which I am here, the sign is going to have to flip. The sign flips immediately in the next step. So -2 divided by -2 is 1. That's good. We wanted x by itself. -10 divided by -2 is 5. So x has to be greater than 5. So how do I check this? Well, I can't check every single number, because anything above 5 is going to be a possible solution. But I can check some number above 5. Maybe I check 6. And I can plug it in here and I say, okay, 6 plus 3, I want to know if that is less than 3 times 6 minus 7. I plugged 6 in for both. So here's 9. 18 minus 7 is 11. Yes, that's true. If you want, you can also choose something less than 5 and make sure it doesn't work. And then if you're asked to graph it, it's greater than or equal to 5. And so where are the solutions? Well, from 5 to infinity. Both of those get parentheses in this case. Okay. Now, one thing to watch out for. Let's say we have another example, and I am here. Positive 5x less than -20. And I say, okay, I have to divide by 5. Just because there's a negative in my problem, and there's going to be a negative here when I divide, does not mean the sign flips. The sign only flips if what you're dividing by, or multiplying by, is a negative. Okay, so just watch that. All right, so that's what I'm doing about the inequalities. You can see on the notes, there are a couple pages of examples. Okay, you can try those, and then I'm going to stop this and come back with a short video just to remind you about graphing and slope, and that will get us through those review topics.